Okay, so Martin has a metal solid consisting of a cone joined to a cylinder. Okay, you can see here. And this is the radius of the circle formed at the join between the cone and the cylinder is r, so that's clear there for us, right? And the height of the cone is 3 times the height of the cylinder. Now what's interesting here is they tell you, look, the cylinder has height 10, right? So they told us that, it's in the diagram, but they've also said the height of the cone is 3 times the height of the cylinder. So quite clearly then, the cone is going to be 3 times it. So times 10 by 3, so you get 30 centimetres. So that's easy enough. It says then he's been asked to make a solid hemisphere of radius 30 centimetres. And it says then he melts the metal solid, okay, consisting of the cone and cylinder, and recasts all the metal to make the hemisphere. So calculate the radius. We're going to calculate this radius here, yeah? So we can go about this by thinking about this object first. Alright, so if we work out the volume here of the cone, okay, to start with, now the formula of course for it is 1/3 pi r squared h for a cone, right? So we'll have 1/3, keep the pi there, yeah, because this is a non-calculator. R squared, well we don't know what r is, so we leave it there as r, and then we'll have r squared, and then h then is 30, okay, so my height is 30. Now, just like we discussed before, it doesn't matter what order you multiply in, so you could put that 30 at the front, after the third, and then 1/3 times 30, of course, well, 30 divided by 3, which is 10, okay? So, 10 pi r squared. Do the same then for the cylinder. Okay, cylinder volume then is pi r squared h. Okay, so pi r squared, the height we know is 10, so that's just going to be 10 pi r squared as well. So the total vol of that original shape will be those two combined, so you just got to add them, so 20 pi r squared. Okay, now this metal then, when it gets melted down, has volume 20 pi r squared, and it creates this hemisphere. So we can say, look, the volume of the hemisphere is equal to 20 pi r squared. Okay, simple as that. Now, for the hemisphere, okay, we need the formula for that, right? Now, they don't give us that on page 2, but they do give us the sphere, don't they? The full globe they give us, which is 4/3 pi r cubed. So you can sort of look at that and think, well, the hemisphere is half of it. So instead of 4/3 pi r cubed, it's going to be 2/3 pi r cubed. Okay? And of course, we know the radius of this hemisphere, so we can put the radius in here, yeah? We can say 2/3 pi times 30 cubed equals then the volume of this hemisphere, which is 20 pi r squared. Okay, so then we're going to do a bit of maths, so we're going to work this out here. So 2/3 pi, now 30 cubed is 30 times itself and times itself again. Okay. We can work out, but perhaps before we work that out, I want you to notice there's pi's on both sides, so we can cancel them out, right? Okay, it's still going to be balanced and equal if you do the same to both sides, so let's get rid of the pi's. Let's work this out here, so keep the 2/3 where it is. Work this out, this is easy to do, because you just do 3 times 3 times 3, which is 27, and add the 3 zeros, okay? 1, 2, 3, you get that equal to 20. Now 2/3 of 27,000, 20 r squared, sorry, 2/3 of 27,000 can be done. You just divide it by 3 and times it by 2. That's what 2/3 is, isn't it? Find the third first, divide by 3. So divide this by 3, 27,000, you get 9,000, and then times it by 2, you get 18,000. Okay? Take then the 20 over, so I'll do it up here. So then r squared will equal to 18,000 divided by 20. Zeros will cancel, so we get r squared then, well, 1800 divided by 2 is going to be 900. And r, well, we can square root 900. Actually, 900 is a square number. If you think about it, 30 would work, wouldn't it? Because 30 times 30 is 900. Okay, so 30 centimeters is our radius.